All right, friends. So let's begin the session. All right. Strange. All right, so let's talk about the libraries. We have Numpy first to start with. So as part of today's session and tomorrow's session, we will be doing data preparation and data manipulation related commands. And of course, we'll talk about these packages which are required for us to deal with data science, right? Data science, data analytics related coding. All the other things that we discussed is basically to understand the capabilities of Python programming as a programming language itself. Now, how much of that is going to be relevant for you to write codes and all that, you have to relook into it, okay? But those are features that you might want to consider when you are developing any of your code. Now let us talk about these libraries. To begin with, we have Numpy library. What is this Numpy library used for?
The numerical Python. It is for the numerical calculation used for Python programming.
Right, okay. Let me set this. If people are saying there is some background noise, let me just check. Give me a minute, friend.
Numpy is basically used for arithmetic operations. But remember, Numpy is not very simple library. It has a lot of capabilities. When we talk about arithmetic operations, it's a huge list of operations are there. And you can do dir, the package name, to list out all the packages that it can showcase to you, right? All the packages that it has. So here we are saying import numpy as np, and we are calling as x is equals to 10, 21, 3, 14, 15, 16, right? So those values. This is a simple arithmetic operation. You are creating a list and you are doing a multiplication of 2. Now when I do this at the list level, if you see here, it is just duplicating the values itself. Right? It is duplicating the values itself. Then we have y is equals to array. This is something that we have already done. Okay, I'm just quickly walking through this part. So we have already seen this, right? When you say type, it is going to talk about ND array. This basically means n-dimensional array. Because we are defining that variable as array. Now array is a data type which is handled by NumPy. Okay? So you just multiply it with 2. But now if you observe, the multiplication is happening on each record. Okay? Small difference. Here you are treating this as list. Here it is array. For array, it is taking the value and multiplying for each value. Whereas for list, it is not taking each value, it is taking x as an object, a single object. Right? And it is multiplying x twice. All right. Then you are basically verifying these conditions. If you say y greater than 10, you can see it is just answering whether that condition is true or false here. Whereas if you look at this, y, the list, right, it is printing those values which are, sorry, yeah. This condition is going to give you true or false, right? but you are saying y of those values. That means it is printing y of true. It doesn't consider false, it prints y of true values. Then we have your memory savers. Okay, somebody is switching on your cameras, please switch it off. We're talking about memory savers. The array basically shares the memory. Right? Look at this. What does that sharing memory means? You're creating A as an array. This is an array that you're creating. A is equals to np.arrange, sorry. So it's a simple array that you're creating, or you can say it's a list basically. Now arrange means it's a sequential data which will basically create from 0 to n minus 1, 0 to 9. Then you are defining B as a list of A values, right? A is just a sequential number. By default, it would be array. Then you are taking those values and assigning it to B, right? You're printing np.shares underscore memory A comma B. So it is checking whether memory is getting shared between A and B. Remember, lists are mutable, right? So this is another point that you need to look at. Because it is mutable, you can basically assign it to multiple values. Whereas tuples are immutable, so it will not get assigned. I mean, when you're trying to create a variable with a value, it is going to give you a specific, right? And it doesn't share the memory locations. Okay, that's something that you need to observe. You'll see that. Right, next. You can just print it A comma B. You can see that A comma B you are having. Here I'm not passing all the values, right? I'm basically taking only even numbers. Double colon basically means take every alternative number, second number from the beginning. Double colon 3, if you put 3 values, it will take. Then we have masking arrays. You're masking, basically masking means you are filtering out. So if you look at this, same array I'm creating, then I'm printing A, this is your values. Then you're trying to mask. Mask is a function which is going to capture those values. You can also say not equal to that. That's also something that you can do and use mask function to print odd numbers. These are all inbuilt functions which are right available with arrays. Then you have matrices. It's not array, remember, it is matrices. The first day of the class we discussed about one-dimensional, two-dimensional arrays, remember? Then we've also covered matrices. So it is Numpy has matrices. The difference between 2D array and matrices is that here you will have fixed dimension. All the columns should have fixed dimension. Then we have broadcasting. All these are few features. I request you people to run through them. Right? You're basically creating your Numpy array. You're arranging the data here. You're basically generating 4 values: 0, 10, 20, 30. Right? N minus 1 is taken, and this 10 is the increment. When you say arrange, it's going to increment like that. Then you are calling B also, and you are here checking the shape. Shape basically means a dimension. So A dot shape, you can see it is a one-dimensional data, right? It says 4. And what is the value? It is printing this value. Similarly, you are saying B is an array. This is the shape for B. If you want to add extra access, you just say np.new access. And it is getting added new access. That means it's now converting the one-dimensional array into two-dimensional array. Right. Then we are printing here, print A, print B. So this star basically is going to put a separator there. And you're adding these two. Right? And you can see how it is getting added here. 0, 1, 2, matrix addition, right? So 3 by 3, you know, matrix operations. So we are doing those matrix operations here. You have to refer to your matrix calculations to understand these things. A plus B. Then we have pandas. As I said, I'm not spending much time here. We have to go to data pre-processing inference, right? So next we have pandas. Now one thing you need to remember in pandas is that it is working with two objects. One is series, the other one is data frames. Pandas works with or understands these two data objects. There is nothing but a single column object, and here you will have row and column, multiple columns. This is your table. And in table, if you have a single column, then it is called as series. Right? Yeah. It's there, Surinder. It's there in the zip file. Please check. All right. So we are importing pandas, and Numpy is basically arithmetic operations, and your pandas is the data. I mean, it's a package which is basically working for creating your data frames, right? So here I'm creating the data frame, creating x1 and x2. It is a list, simple list, and I am also creating x3, which is a list. But here I'm saying only 4 values, from 5 values, 0 to 4. And then we are creating a data frame here with these 3 columns. Okay, let me run this line by line here. This is something which is you need to look at, so I'll just execute this. There are a few points that you need to understand. All right, so we are importing pandas and NumPy. I'm creating 2 lists. Each of them have 5, length 5. And this one is having, okay, here also I have 5. Okay, so when I create data frame, what would be the dimension? X is pd.data frame, columns is x1, x2, x3. What would be the dimension of this data frame? Not 1 by 3, not 5. Not 1 by 3, 0 by 3. Why 1? This is only a column names. It would be 0 by 3. This is the shape. You can see. If I highlight, you can see it's an empty data frame. It's only creating the structure, and you're putting them in quotes. That means it's a string value that you are assigning there. Right? And in order to add the values to it, you can pass this code. X of x1. Right? So this list is getting converted into Pandas series format here. Right? When you want to refer to the data frame components, the columns, then you are going to have 2 options. One is this. The other option can be x of x1, x dot x1. You can also do this. X1 is not defined, so I have to execute this, and then execute this. So this is giving us data frame. Okay. You can also first convert data frame and then add it. Here it is automatically converting the values to data frame, series from list. Whereas here you're converting first the list to series form. You're saying pd dot series, right? You're converting it into series form, right? Then yeah, this is another way. As is mentioned, you can either refer to x of x1 or x dot x1. Both are going to talk to your column only. Different representation that we have. Either this or this. Both are same. If you want to refer to two columns, then you're going to call like this. Double square brackets should be there. X of x, your column names are x. And what are those names that you have to mention? Right, those things will be in your another square brackets. So double square brackets would be there here. This is going to give you two columns. Now the challenge, this looks very, very easy to practice, right? X dot x1. For using that, it looks very easy because x of x1 that you're typing is going to take a lot of effort. Right? X of x1 is taking a lot of effort. So, the problem with this approach, x of x1, is that if you want to refer to two columns, you cannot do that. Using that syntax, you cannot do. You have to use this. Right? So, this is a drawback. It gives you two columns. If you want to refer to any specific set of values, then you are going to execute this way. And always remember, when you represent these square brackets for a data frame, whether it is in R or in Python, it will always talk about rows and column arrangement. Data frame is rows and columns, right? So by default, that would be the structure. But in R, we have the index starting from 1. Whereas in Python, it is like any other right, programming language, which has the index starting from 0. So when you represent this data using ILOC, this basically means index location. Right? You're talking about index location. And you're referring index of rows and index of columns. 0:3. Index for rows starts from 0. :3 means n-1 should be taken, right? It starts from 0, but n-1 should be taken. Isn't it? And then 1 means column also starts from 0. Column index will also start from 0. So 1 means this column, the second column. So that's the reason why you get 10, 11, 12. These values, when you say 0:3, comma 1. Remember, index starts from 0, whether it is rows or columns. Okay, it can be rows or columns. And whenever you're representing this range of values, colon basically puts range, right? Lower limit, upper limit. The range will always start with lower limit and it extends till upper limit -1. Right? So this is basically your data. Xi location 0:3, 1. This is your data set. Then we also, right, can represent colon, colon, which basically means everything. This is also something that we have seen. Remember in the list we use this, right, to represent and record the data. because index is a list. We are using those features here. You can also refer to LOC. When you say ILOC, it's more like an integer location, or you can say index location. Okay. You also have exact location of that particular object. Here also you can pass rows, comma, columns, and when you say LOC, it is taking as is. It doesn't treat those values as your list, and hence it is not looking at the range as n-1 values. It takes all the values that you are specifying there. Okay, that is LOC. So we have ILOC and LOC, two things. Understand the difference there, okay? Generally, when you say LOC, you directly represent to your data points. You don't refer to indexes. Right. Then these are few options or operations that we have. We have two data frames, two different data frames, and you want to merge the data frames. Very simple, you apply merge function. Pandas has merge function, but when you are merging it, you need to specify a keyword. You have to specify a key feature or key on which the merge should happen. So you're saying x1, x2, x1, x3. We don't have x2 in data frame 2 and x3 in data frame 1. So when you're referring, x1 is a column which is common in both. So we are executing the merge option based on this. So you have x1, x2, data 1, data frame 1, data frame 2 having the 1, 2, 3 sequence as same. 4 is not there. So you cannot merge that. It ignores 4th row from data frame 2. Because you are merging on x1, it records or it compares these records using x1 as a key. Then we have join operations. Now joining is happening based on, again, your OOPS concepts only. Joins are very, very old concepts, right? You have outer join, inner join, left outer join, left inner join. So that those things are getting executed here. Joining operations, df2.join df1. So if I take df1 and df2, right and left, df1 is left, df2 is right, then what is this join? df2.join. What is this result? Is it called as right outer join or left outer join? What should we call it? It's called as nobody else? Nobody else answering? We are saying df1, df2. Right outer join, exactly. You're considering everything in df2 first. First record df2 and then see whatever things which are there in df1 which are similar to df2, take those things. Right? So if you see here 2001, 2002, these are the two records which are common in these two. But 2003 is there in data frame 2, whereas it's not there in data frame 1. So NN is put there. This is a simple transaction of your data manipulations, Pandas. Then we have replace function. You're going to replace and in place Yesterday we were discussing about in place, remember, with respect to sort and sorted. Sort basically is an inbuilt or in place function. It is going to affect the data that you have originally stored. Right? It is in place. Your values are getting affected. And here I'm putting this set index as x1. In place true. That means the data object that you have here is getting affected with index. By default, Python gives you an index which starts from 0. But here you are using this key function called set index, which is going to change that 0, 1, 2 to 1, 2, 3. That means your x1 becomes index now. Right? If you have, let's say, an employee table, when you are uploading it, Python gives you a serial number by default, index. But if you don't want that, and if you want index to be considered as your employee ID, then you can just say set index as employee ID and job done. Yeah, then we have column names changed. This is something that which comes very handy, because when you are uploading the data, right, your variable names might have spaces, special characters and all that, right? Because data is coming from somewhere else, you are not creating it. And there might be different nomenclatures used for this particular, right, column names. But when you are working with Python and when you want to work on, right, doing some kind of transactions on that particular data, then it makes sense for you to look at the variable names with standards. These variable names will have certain standards, rules. Those rules have to be followed. So you might want to edit those column names. You can do that here. Right? So x1, x2, that is your data frame. When you say print, you get this. And here you are saying rename. df dot rename. What you want to rename your data as? You're renaming column x1 to x3. And when you say again print, you can see x1 is renamed with x3. So let us execute this. Rename is a function which can be used for renaming your column values. Any single value you want to replace, you can use that. If you want to assign completely new names, then this is, you can just say df column names is equals to this. Then we have concatenation. Concatenation basically is just combining. And here you are concatenating the data, and we are, look at this, we are considering this as a list, okay? It's a list data. So data frame 1, data frame 2, concatenate these results. And you have index. You're defining your own custom index. In the previous cases, previous examples, by default, an index was created. Then you are setting one of the column as index. But here, you are not setting any existing column as index, but you are saying create new sequence for your index. Right? So this is going to create your data frames separately like this, and then you are adding them. Just concatenate it. 2001, 2002, 2003, 2004, 2005. One after the other. First you put D1, then you put D2. That's it. Combine. Vipul, you need to understand what does joins means to understand why 2000 was not taken and why 2003 is taken. Try read joins. Okay. There are different types of joins. You have to go through them to understand that. Now, importing a data set, we have this function, right? Read underscore CSV. Now, as I said, your pandas is going to work with two objects. One is series, the other one is data frame. Now, if you're having a CSV file, a data which is having multiple columns in it, then by default, your data is going to be read as a data frame. If you're passing data which is a single column, then by default it will be interpreted as series. So here in the educational data set, we have three different columns, right? I'm calling it as MBA, right? And type is giving us this is a data frame, and shape is going to talk about the dimension. How many rows and how many columns are there? It is showing the shape. MBA dot head. This head function gives you 0 to 4. That is total 5 records. You might say that, okay, I want to see top 10 records, 0 to 9. Then you can mention here that number. You want to see first 10 records, you get 0 to 9 printed. You are going to mention that number inside that parenthesis to look at the top, right, few records. Whatever the records that you want to publish there. Then value underscore counts is basically, if you are familiar with R, then there is a function called table in R, which is similar to that. It is going to count the unique values that we have in the data. So we have data, serial number, work experience, and GMAT, right? So you take work experience and look at the number of times each value is repeated, unique value is repeated. Okay? And then it finds on how many times this value is repeated. Friends, these are all already covered, I'm assuming, for you people. That's the reason I'm going a little fast here. If you're saying these things you have not done till now, are you saying that? You have not loaded the data? I'm assuming stats has done run. Stats was done for you people. Please confirm on that. Yeah, that's the reason I'm going a little fast. These are very simple queries, friends. You have to just run through them. Whenever there is a complex command that is coming which needs explanation, I'm taking time to explain. Okay? These codes are there. You just run through them. It's just straightforward application. Okay? Right. So here we have value underscore counts. I'm trying to explain these kind of commands, right? Focus on that. So if you talk about work experience here, how many total values are there in our data set? We had 773 records. We have already seen that dimension. 3 columns are there, 773 rows are there. Right? Now, in this case, you are talking about one single column. Okay, you are talking about MBA, one single row, sorry, not even column, one single row that you're talking about here, which is 1. When I say this 1, what would I get? For this command only, the circle that the value that I'm highlighting, what would I get here? It is going to give you index 1, which is these values. Value underscore counts is a function which is going to look at the unique values in that particular variable, and it is going to count how many times those variables are repeated. For example, here I am passing a single record, 1, and it is going to give you this count, right? Now, if I remove this and execute, let me add this new row. I'll say MBA dot value underscore, let me say MBA dot workx. Okay, I'm taking MBA dot workx, and then I'm going to call value underscore counts. When I do this, what it is doing? It is counting the repetitions. How many times each value is repeated then. For work experience, but unfortunately I don't have same values repeated, so you don't get anything there. When you have repeated values, we will look into this value underscore counts again function, okay? It's like table function. It's going to count the number of values, unique number of values, how many times each value is repeated. Then we have describe function, which is like your summary. But looking at the describe, if you are familiar with box plot, right? If you're familiar with box plot, then you can see here, describe is going to give you those calculations only. It will talk about minimum value, maximum value. It also talks about first quartile, median, third quartile. 50% is median. Then we also have additionally standard deviation and count given. Mean is also there anyways. Right? So this is calculation done for each column. Summary, it's basically showing you the distribution. So these are few of the regularly used commands with respect to Pandas library, data frame operations or series related operations. Then we have Matplotlib. Matplotlib is used for what? Visualizations, right? That's what we are trying to see, visualizations. The simplest and the easiest visualization in Python is histogram. I mean, we have other visualizations also which are easy. Hist on your GMAT data. But in order to import it, in order to use hist, we need to import this package. Matplotlib.pyplot as PLT. You're going to import that. And you see this visualization, it's going to give you frequency distribution for this particular data set. Right? You already know histogram, isn't it? Or do I have to explain histogram? Frequency distribution plot, right? Histogram. Wonderful, yeah. Then we have box plot here. Box plot, the function is same, box plot only, like your name. And you're passing your variable name on which you want to come up with the visualizations. All these visualizations that I'm showing are univariate visualization fields. Okay, single variable is considered here. So you executed it, it is going you this particular calculation. And plt.ylabel, this is an argument that you are passing to label your data. On y-axis, you want to show that these values are GMAT values, because that's what you are trying to check, right, on the graph. You can also alter your values a little here there, and you can see box plot MBA GMAT 1, rs comma 0. Now, what does this actually means, right? You might want to understand. Now, if you're working with Spider, it becomes very easy. Let me load this. I'll take this box plot, the nudged one, and I will show you those parameters. Okay, so let me import Matplotlib pyplot, and then you're going to execute this box plot. But let me show. You say plt dot box plot. I'm right selecting it. This is a sticky note, which is a new feature in Spider. Now you can see X is your data frame. Notch, you're saying none. By default, it is none. But here, you're passing those values. You're saying X, that is the minimum required data. You're saying MBA. Then you can say dot gmat, comma. Now I put comma, right? If you see here, before comma, X was getting highlighted. Now, after comma, notch is getting highlighted here. Right? By default, it is none. By default, it is none. That means 0. Here I am saying 1. That means I want notch. Again, when I put comma, it is selecting that. SYM is equals to none. Then you can put some values and then, right, you can move on by, right, play around with this option. You can add more values like this. What is the positions? Where do you want to put this value? Right? All those things can be done. Now, R and S that you are seeing, these are red color and square shape. Red color and square shape, and 0 that you are seeing here, is basically your vertical. VERT is vertical. By default, it is none. Right? That basically means 1. Here you are going to put 0. Right? By default, it is none. Vertical is none. That means it is going to plot you a straight value. Right? Vertical image. When you say 0, right, it is going horizontal. Generally, we say horizontal and vertical, right? That's how we read rows and columns. So horizontal will become 0. Right? That's what we have here, the command. And if I execute it here, you're going to get this notched red color image, squared images. So when you say notch, you see this at median, there is some nudge created. So that's called as notch. Just to show you the right visualization in a better way. Here you don't have notch, here you're putting a notch. Then R means red color, S means square, 0 means horizontal. So these are, these are basically your visualizations and box plot. Then we have bar plot. Now older versions had a different right, query. Here we have a different thing. The new versions have different thing. I mean, it's pretty some time now, probably 1 year back or so, we had bar plot, older version function, which used to take height as, no, not height, sorry, my bad. What is this used to be? Length. If I'm not mistaken, it used to be length. So height basically is your bar. Length is basically this x-axis values. In the older version, it used to have length, but now they have renamed it, saying that the x-axis values. Remember, bar plot is a univariate analysis, right? You basically take one variable at a time. You don't need so many variables. So they simply said, I know I'm plotting the bar plots with height on y-axis. In that case, what should be there on x-axis? It should be an index. So you're simply putting x there. You're reducing the complications. This is the latest version of bar execution. Right? You got this bar plot. Now I also have a data set called empty cars. I'm loading that. Now, when you're trying to load this, you make sure you're giving complete path, and that too using backward double slash. Right? When you're trying to print this, your Windows C:, this is how your Windows looks like, right? And this one. Isn't it? This is backslash. Now Python would not understand this backslash. It understands a forward slash. So when you're passing the data set, make sure you're passing the data set with either the backslash or double forward slashes. Backslash or double forward slashes. This is something that you need to pass. Now for my execution, I've placed this empty cars directly in my folder from where my executions are happening, right? So I've directly put my codes there. You can see, let me go there. This is the location from where I have my empty cars, my Jupyter notebooks are launched. So empty cars, if it is there in this directory, then automatically it will pull out. You don't need to give the complete location. So it is going to read the data directly from that location, and it is giving us shape, the dimension of the data set. Again, if you say head, it is going to give you the 5 records. Head is this. From 0 to 4, all the 11 columns it is showing. Then if you're trying to visualize a single dimensional data, then line chart is what you need to prefer. Single value if you want to, right? But yeah, your line chart would make sense when you have continuous variable, and bar chart makes sense when you have discrete data for that univariate analysis that you're doing, right? If it is continuous, use a line chart, and if it is discrete data, then use bar chart. Okay? All right. Next. Let me execute this. You're putting kind is equals to line, but you're using a group by function. Group by function is going to take the records and combining those records. If you observe here, you're grouping the data, this data, using gear option. You have 3 gear, 4 gear, and 5 gear vehicles. But you have multiple 3 gears and multiple 4 gears and multiple 5 gears, right? So you're combining, aggregating 3 gear vehicles, aggregating 4 gear vehicles, and aggregating 5 gear vehicles. In the 3 gear vehicles, or in the 4 gear vehicles, we are looking at the mean. Sorry, the mileage, my bad. You want to consider the mileage, aggregate the mileage, and then plot the mileages of only 3-gear vehicles, only 4-gear vehicles, and only 5-gear vehicles, separate. So that is what your group by function can do for visualization. Now, if it is a discrete data, then you can do bar plot. Here I am doing pie chart. And remember I said value underscore counts. Let me show you that. So here I am adding another function. So I'm just selecting that part, value underscore parts. If I execute this, you will see that it is going to give me 3, 4, 5 gears and their respective count. Value underscore counts. So if you look into the data set, or if I just say empty cars, the full data set, then you have 32 rows, 11 columns. One of the column is gear. Now if you look into the gear, as I said, it has 3 gears, 4 gears, and 5 gears. You can see those 3 different colors. How many gear, how many of 3-gear vehicles are there? 15 vehicles are there. In empty cars data set, 15 cars are there which are 3-gear vehicles. 4-gear vehicles, 12 cars are there in the data set. And 5 cars belong to 5th gear vehicles, 5-gear vehicles. Okay, Upendra, which image, Upendra? You're talking about these data points, right? You have a cars data set, empty cars data set, which is talking about segregating the data based on the gears. And then we are plotting the mileage of all the 4-gear vehicles, 3-gear vehicles, 4-gear vehicles. Here, okay. 32 rows are there, right? And in 32 rows, one of the column is gear. And what is that gear saying? Or that column is a discrete data. It has 3-gear vehicles, 4-gear vehicles, 5-gear vehicles, right? These values are repeated. I am segregating the data, 32 rows, I am separating this data and taking all the 3-gear vehicles aside, 5-gear vehicles aside, 4-gear vehicles aside. And in this subset of data, I am looking at mileage column. And you're plotting those mileages so that you're comparing the performance of these vehicles with respect to mileage. Whether 3-gear vehicles are better, 4-gear vehicles are better, or 5-gear vehicles are better. Yeah, sorry about those terms. Yeah. In line chart, can we give? Yes, absolutely. You can give, Pradeep. We have y-axis, y label, x label, right? All those things will be there. And yes, we can absolutely do that. Yeah. What does that mean, Sundar? I didn't understand your question. XA, XI? Oh, x-axis, is it? No. X-axis is the records. Y-axis, the mileage. How many records are there? Again, 32 records are there, right? From 0 to 31 records you will have. So those records are plotted here. Yeah. All right. Next we have pie chart. So I'm taking value underscore counts, which is basically giving us this breakup. On these breaked up data, this summary of your data, you are putting pie chart. Plot kind is equals to pi. Now it is going to take these values and arrange the data automatically on the breakup. We have 15 records for third gate, so it is occupying the majority of the space. Then 4 gate and then 5 gate. Colors and all those things you can change. By default, it is taking these colors, but you can always change those colors and all that. Then we have something called as area plot. On mileage, whenever you have continuous data, you can use line chart or area chart. Line chart or area chart. It's just like line chart, but the area under the line is getting shaded. If you say line chart, then this would be the line chart for you. For this thing. Only that pink line would be shown. But when you say area, this entire area is getting shaded. Right. This is about your area chart. Then we have bivariate analysis. All the visualizations that you have seen till now, whether it is pie chart, whether it is area, whether it is line, histogram, bar plot, or box plot, all these visualizations that we have seen are univariate analysis visualizations. Single variable is being plotted. Okay? Now, when you talk about two variables, right, then the default visualization will be scatter diagram. When you're plotting two diagrams, two values in the space, XY space, then it is called as scatter diagram. But if you can carefully observe here, I still use only one variable, mileage. Right? But you're using the index and then plotting those values. So this is not a bar. When you say plt.bar, the bar plot was predefined function which is going to consider those x-axis values and height as y-axis values. It takes those parameters and gives you that visualization. But if you say plot, plt.plot, based on the data that you are passing, it is going to execute these results. For example, here I am saying plt.plot, two variables are passed, x comma y. So x-axis, y-axis, it's plotting the data. But here if you say plot, you're saying area plot. Right? Here you say why is this? FPG. You can directly say area, or you can say, okay, you need to pass this one. It's mandatory that we need to pass kind. Okay. Experimenting. So it's a few arguments are not required. Okay, don't need to specify those argument names. Directly you can pass the values and it would take, like box plot we tried, right? If you remember here in box plot, you're not saying what is this, automatically it is interpreting. Whereas here for area chart, for the plot function, you have to mention kind is equals to, you have to pass that. Okay, right. So this is the interpretation based on the values that plot function is taking. it is going to decide on what kind of visualization it has to do. Now this is scatter diagram, but we are not defining it as a scatter diagram. We are just saying plot. And yeah, till here you have univariate analysis. Now Seaborn, what is a Seaborn? Seaborn is a library which is giving you enhanced visualizations. Okay, it gives us enhanced visualizations. So we have already seen box plot, right? But that was from Matplotlib. And here we are passing the box plot which is defined from Seaborn library. We are passing here continuous value. And you can see it gives you an enhanced visualization. It's not like your, right, the regular box plot that you have seen here. So you're basically saying GMAT data, right? MBA GMAT. And here you're passing empty cars gears. So if I say sns.boxplot, fine. I'll say MBA.GMAT. SNS is not defined. Oh, it's not imported. Sorry, mine. It's still executing. Yeah, executed. Similarly, I'm doing now sns.boxplot. MBA.GMAT. So you can see the difference between the two visualizations. SNS is an enhanced visualization library. In scatterplot, what is RO? This is not scattered plot. This is only a plot. But because you are plotting the data in two-dimensional spaces, by default, we give that visualization a name called scatter diagram. And the R and 0 basically are red color. O means data objects. If you don't pass these, see what happens, you'll get a line. If you put O, then that basically is objectifying objects, data points. R basically is color. All right. Now this is a scatter diagram. SNS dot scatter plot. And you can see mileage, horsepower are the two values that you're passing from your empty cars data set. Continuous values have to be there on x-axis and y-axis. You cannot take gear. If you take gear, you'll get, right, the notches. Like poles is what you're going to get. For example, say you're taking, okay, I'll change this to gear. Or let's say x-axis I'm changing to gear. Look at this. You get three different lines which are having the data points. Right? So always try and have a continuous value for for your visualization on a scatter diagram. You can remove that HUE and execute it. It's going to give you default blue color. But when you put that HUE, right, it's basically changing the visualization and gives you different colors for different categories, different cylinders. It's a three different categorical cylinders that we have in the cards, empty cars data set. We have 4 cylinders, 6 cylinders, and 8 cylinders data. And when you talk about empty cars, you can see it is basically having different colors. 3, 4, 6, 7, 9. In your empty cars data set, it's showing those Those are the different kind of colors it has. Range, color palette. Here it is taking only 3 cylinders, discrete data. Right? It's clearly showing that there are only 4, 6, and 8. Alright? Here I'm putting bar plot, but I'm segregating the data using hui or cylinders. Right, so this is basically your value visualization. Now, you see this X ticks. This X ticks is a parameter which basically gives these labels of the numbers that you're seeing on the X-axis and Y-axis. X ticks rotation is equals to 90%. Right? It is rotating 90%. If you don't put that, you'll see 52 like this, regular letters. So this is the command which basically, this is the parameter which basically alters your ticks, these values. You can also adjust the font sizes, styles, and all those things can be done using this argument. Then one interesting visualization we have, which is called as violin plot. Right? Violin plot. SNS.violin, empty cars.get. You can give any value here. This is your gears. You get this violin plot. You can put cylinders here. Again, it gives you violin plot. Changing the shape if you observe. You can say horsepower. You get a different visualization. But it is like, right, violin shape. Right? It's like a violin shape. Hence, it is called as violin plot. Next. You see here, this is a multi-variable visualization space. On the diagonal, we have histograms for the columns. And above this diagonal and below this diagonal, we have replicas, mirror images. Let's say this is A, this is B, this is C. On x-axis, you have B, y-axis, you have A. The same data, on x-axis, you have A, and on y-axis, you have B. So it's like transposed mirror images. Right? So that's your pair plot. We call it as pair plot, which is nothing but multiple scatter diagrams along with multiple histograms. Combination of both histograms and scatter diagrams. Right. It's just the spread of the data that it's showing. How much space you're occupying, right? That's how it shows. So for example, MPG. So majority of the vehicles have mileage in around this area. Somewhere here, around, right? 17, 18. All right, so these are all visualizations. Then you can also do joint plot. We are combining the visualizations, right? And you have basically the scatter diagrams and histograms coming like this. Okay. And no, whether you cannot, pair plot is fixed. It basically has, right, the fixed histograms. That's the standard. Okay. Then we are having a lot of additional packages. We have seen, I should say, Matplotlib and Seaborn, but we do have a lot of, right, these libraries, third-party libraries, which can give you very well developed nice visualizations. Bouquet is one such package which runs on JavaScript, HTML pages and JavaScript. You cannot run, basically you will not be able to appreciate Bouquet. It doesn't work with Spider. It needs HTML pages. You can try and see this. It says it's not available. Command itself is wrong. Invalid syntax. Right? If I say pip install Matplotlib, right? It will work. Whereas Bouquet will not work. Okay, let me show you. Inline, right? Yeah, this will not work. Okay, let me just execute here, notebook. In Spider, it doesn't work, guys, but because it needs HTML pages. Okay, let me not get into errors now. If I execute it again, Spider will throw errors and all that. Now, Bouquet is a library, as I said, which works with HTML and JavaScript. Okay, and there are two ways that you can publish your visualizations. One is output underscore file. The other one is output underscore notebook. Output underscore notebook means the visualization would be there in your notebook itself. Output underscore file means you are going to come up with a new HTML file. Okay, I'm not spending time on this because this is something that we are not regularly doing. Because we have these packages, I'm just explaining. I'll run this code and you can see this is going to generate these circles on the data coordinates 1, 4, 2, 7, right? So it's going to generate that scatter plot here. It's a nice visualization that you're going to see. You can also save this visualization, right? You can pan out and yeah, this is going to be redirecting you to this Bouquet. This is the library. It's an open source library. You might want to go through this. There is a huge documentation that you can play around with. Right. So this is about Bouquet. You can also do bar plot. Now you see there is a HTML page created, bouquet.plot. You're saying bars.html. That is because you have defined output file and you're defining the name of the HTML page. So it creates those HTML pages. Automatically it renders the visualizations as well. This is also something that you can do, scatter plot. This is how your scatter plot looks like. Right? Now, when you're hovering your mouse, the values are not being shown because you have not defined those parameters for bar plot. Whereas if you see here, it shows so many details. Right? Index, data point, XY, screen, all those things are shown here, right? Now that is because you're defining those things here. So these are the tools that you have defined, saying wherever you put t values, you're going to showcase those values, right? And you're defining those figures. Then we have Plotly, another library. This is also similar to Bouquet, open source library. These are all organizations, okay? They develop these softwares and they give to community. And this is how your Plotly looks like. Yeah, this is your Plotly. And if you see, by default, Plotly is going to show you the value of the data set. I mean, that value on the screen. Here you are doing bar plot. See, if I hover my mouse, look at it. It's giving me the values. Similarly, you do pie chart. This is your pie chart. Visualizations, those right example codes are there. You just walk through them and try to use those things. There are a lot of inbuilt widgets. You can do help commands to understand more about the options that are provided there in the bouquet and plotly. And whenever you want to use them, make sure you are installing those libraries, and you just have to say pip install, right? Plotly and pip install bouquet. But as I said, remember these things will not work in Spider. You need to have a HTML UI. That's notebooks. Right. So that's about visualization. Then we have SciPy, a little complex library. It does a lot of advanced mathematics. And right, we are going to take. Okay, yeah, Nitin. Yeah. I was wanted to complete Matplotlib and those visualization libraries. So 9:27. We'll come back at 9:35. No, Sanjay, I'll discuss. There are a lot of more things to be discussed. Not missed, not skipped. We will cover that. Hey guys, is everyone back? Upendra, I'll take your question at the end of the session, okay? I'll take questions at the end. Not now. All right, is everyone here? Okay, wonderful. All right. So we discussed about Numpy, we discussed about Pandas, we discussed about Matplotlib, we discussed about Seaborn. And of course, we have also seen Bouquet and Plotly. There are two different enhanced visualization options. Then we have SciPy, which is an enhanced mathematical computational library. When I say enhanced, it's basically doing a lot of scientific computing for us, right? SciPy, scientific computing. Now, SciPy requires Numpy, right? SciPy is built on top of Numpy only. So when you are importing SciPy, you need to have Numpy also. And we also have something called as SymPy. SymPy is a very interesting library, right, or module that you might want to see along with these libraries. But it is for core mathematics. It's basically calling that, sorry. SymPy is basically nothing but symbolic Python library. So when you have the symbol, right, rational or power equations, right, complex numbers. So when you have these kind of equations, mathematical equations, then those true equations are basically being published, right, using this SymPy. And SciPy does these things: integrational calculations, optimization, Fourier transformations, signal processing, linear algebra calculations, and also multi-dimensional image processing concepts can be done using SciPy. These are all, right, few of the functionalities, enhanced functionalities that your SciPy has. We will not be regularly using it. Rarely we will be using it, but yeah, it's good to know about it. Especially people who are trying to do, right, AI related computation, they basically have to do it. I'm doing integrate function here. Integrations basically. And yeah, lambda is given here, but we're not discussing lambda. Don't worry. We'll again have this discussion. Lambda functions are there. Integration, if you remember those, right, +1, +2 calculations, integrals, calculus, right? Those calculations are automatically done using this integrate quad function. Just apply this. So this basically is equation that you are typing here is x power 2. This is the function, and your lower limit is 0.3, upper limit is 2. Right? This is how you write the integrations, right? Remember? Integral of f of x dx with lower limit and upper limit. So that's basically your equation, and you're integrating that. When you do that, you get result. And this is your integration result. Similarly, you'll have, right, line space is a function, which is, as I said, we are doing all these calculations, but here I'm not using SciPy, if you observe. I'm still using what? Numpy. Though I'm doing these calculations, cos calculations, cos theta. So this is cos of x square, x power 2, right, divided by 2 plus 4. X square divided by 2 plus 4. line space is a function which is giving you values, continuous values between 0 to 2. How many values you are getting? 6 different values you are going to get. Right? It's basically having line space means it is going to have equi-space values. It's going to distribute that data into equally distributed intervals. 6 values you need between 0 to 2. That means it is going to divide the values like this. 0, 0.4, 0.8, right? Multiples of 4. Then you'll get 6 values. Right? When you get this value x, you're substituting those values into this and you're getting your y values. And you're printing those values x and y here, plotting x and y using a red color line. This is your x comma y. And you're showing this. You're printing the output there basically. So this is your visualization. Then linear algebra functions. You apply linear algebra and you're generating a random number. Basically your np.random. Using that, you're going to generate random values. 4 by 4 matrix is what you're creating. Your A is a matrix. And what you're doing there is using linear algebra function of SciPy, you're creating inverse of your matrix. You can also use solve function to do that. It calculates inverse. Right, so this is about inverse. You can also calculate eigenvalues. Again, these are all, as I said, advanced calculations. You're calculating eigenvalues for your 5 by 5 matrix now. Randomly generating 5 by 5 matrix and calculate eigenvalues. Now then we have, okay, this is also a determinant calculations. These are all matrix related calculations. Now let me move on to talk about Fourier transformations. Now when people are working on this Fourier transformation is generally used for signal processing. So any function which is, let's say, depending on time functions, those time functions are converted into frequency functions. That's what your Fourier transformation means. Okay. Now, FFT is a function which has, which is given in SciPy. FFT basically means fast Fourier transformation. It's a library that we have, which is doing ultimately Fourier transformations only. As I said, you're converting the functions. A function which is of time that gets converted into a different function, which is in this frequency space. That's the definition of your Fourier transformation. So we are taking those calculations here. Yeah, I'm generating an array and then calculating fast Fourier transformations on that. This is the values that we are getting. You're also getting complex numbers. Right, so this is about your Fourier transformations. You can also convert this, right, function. Actual application is convert your signal from one function, one form or one space to another space. So I'm generating a random values here. 500 values. The sample spacing that I'm taking is t is equals to 1 by 800. And then you're generating a sequence of numbers using line space function here, which are going to start from 0 till n star t. N is 500 and you're multiplying this with t. That means 800. 5 by 8. How many such values you need? 500 such values you need. From 0 to 5 by 8. And once those values are generated, you're going to calculate sine function. Right? You're saying np dot sine this multiplied by this. There's a standard functions that you're applying there. And you're just transforming your data to different frequency or different space. Okay, this is advanced advanced libraries. So don't worry about these things. When you are doing AI related components, right? AI related tasks, you might want to go through that. Eigenvectors, Pradeep. Again, don't really worry about those things. You'll probably learn somewhere in network analytics. When we learn network analytics as part of your data science subject, right? Eigenvectors, eigenvalues are being discussed. So we can, it's a vectors basically, okay? Form of vectors that you will learn. All right, coming to the most important library, scikit-learn. Scikit-learn is the open source library which is basically helping you to implement machine learning functionalities. Right? All the machine learning functionalities are generally given in the scikit-learn, or you can say sklearn in short. Right? Yeah. So this is scikit-learn or sklearn. You have right, very important two functions. One is sklearn.fit. The other one is called as sklearn.predict. There are right a lot of what do you call the emojis? Not emojis. What you call one-liner statements, paraphrases or something we call, right? Funny, witty statements are there, because when you talk about sklearn, data analysis or machine learning, there will be so many things which will come into picture. But to explain sklearn, right, experts say it is very easy. We look at sklearn.fit, that is for training, sklearn.predict, that is for testing. Yes, of course, that is what you do. But in order to do that, we need to make sure your data is in that appropriate form so that your libraries or your algorithms can be implemented on that. And this is where your data wrangling steps, data pre-processing steps take precedence. Okay, you have to work on those steps, data pre-processing steps. We'll look into that. Now, in sklearn, we have inbuilt data sets also. Right? If you have to import data sets, right, you can go through on what all data sets are available in your sklearn. We can also see dir of sklearn.datasets. If I'm correct, it's not defined. Import sklearn. Okay, let me see. dir of sklearn. Yeah. And these are all the various functions that we have for sklearn. We need to look for. Okay, the data sets is not available here. It's not defined as a package file. Okay, so from sklearn.datasets, it's a different module altogether. We are importing that, and right from sklearn, you're importing these predefined datasets which are available. Try and explore more on those datasets. You can Google for it. I'll show you how to list out those datasets also. dir of the library or a package would basically give you the list of the sub-modules that package has. Okay, for each package, there will be some kind of sub-modules, right? So you are going to basically say dir to list out those things. I was trying to do this sklearn, but yeah, it's not showing the datasets library. It's a different module altogether. We need to look for that. But this is how we basically load the datasets. Now you'll not be able to read it. You cannot just say import dataset and you'll not be able to directly read it. Okay? Here you imported this and you have to transform this data into a proper readable format. Okay? This is loading that particular data. It's a function, mind you. You're loading that data set into data, and then you're going to record the labels and the data points of that particular columns. So it's like a key and value pair mapping. We're trying to capture the key and values. Label underscore names is you're basically calling target names. Target names is the categories that you have in the output column. Okay, and this dataset is very famous dataset. It's called as iris dataset, which speaks about flowers. Iris flower. And this iris flower basically has 3 different species. And those 3 different species details are explained in that particular dataset. You'll come across, don't worry. You'll see this dataset again in future a lot. It has in total 150 records. And if I execute this, you can see it's basically loading. And here it is recording the data. This is the target data. We are calling labels. This is your basically labels. You can also read the input data. Feature names is input data. If you say print feature names, it's going to print those feature names also. You can say this, print feature names. So it's printing this values, right? So that's about the data. When you say labels, this is the data. Names is given as setosa, versicolor, virginica. Setosa is considered as 0, versicolor is considered as 1, virginica is considered as 2. Right? And these features that we are talking about are the flower, sepal length and sepal width, petal length and petal width. Right? And this is your data. You in total have 150 records. And whenever you are trying to implement machine learning algorithms, in order to work with this, in order to see work with this data, I mean any machine learning algorithm, you have to make data partition first. Okay, and in order to do the partition, we have inbuilt functions also. This is your train test split function, which is available again in sklearn module itself. Train underscore test underscore split is going to randomly partition your data. Okay, and you need to specify how much should be that partition. The test dataset size should be how much. Training dataset will always be the larger proportion. Test dataset will be the smaller proportion generally. So we are going to see partitioned data, and whenever you're applying your machine learning algorithm, you're going to apply that algorithm on training dataset only, because you want some data to be hidden from the model that you're developing, so that once the model is developed, you can cross verify on how well that model that you have developed is working for an unknown data or for a new data, right? So this is general practice. When you start with your machine learning algorithms, you should basically see this. And as part of Chris DM initial discussions, I'm assuming this concept is already covered. If not, it will be covered anyways. But to split in Python, we use this train test split library or function. And you're passing two data frames here. If you pass one data frame, it is going to partition it into two parts. If you're passing two data frames or two data points or tables, then it is going to give you four parts. Every data right that you are passing, every data frame that you're passing or array that you're passing, it is going to split it into two parts. Remember that. Right? By default, it will be two parts. So here features and labels will be partitioned into four parts. Train test, train labels, test labels. Right. And you can also check what is this dimension. We are passing it on 24%, right? You can change that to 30%. Out of 150, you are specifying 30% of the data. So it will become 36 into as your test data. Right, so this is how you partition your data. Random state basically means the data is going to be partitioned randomly. Okay, that's what it means. Okay, similarly, you have Bayesian classifier. These are all the models. We are not running these. You'll have to understand what does knife-based algorithm is all about, right? And then we also have metrics. These are metrics to evaluate the model. And this one is KNN model code. KNN again is a classifier, one of the machine learning algorithms. Right? So we will be walking through these when we discuss those algorithms. Right. Similarly, we have stats models. Stats models is also a library which gives us statistical related algorithms, statistical models. Right? Machine learning is also implemented using statistical components, right? Or concepts. So there are a few algorithms that can be implemented directly from this stats models library. Linear regression is applied using stats models. It's a statistical equation, right? So OLS is the concept that we will be applying from stats models. And when you generate this, you will get equation. This is the output that you're going to see. Okay, and this is your model evaluation techniques, influence plot. We'll discuss these things, okay? Yeah, this is something that we need to look at. So in the next class, we will be looking at all these things, okay? We'll try and address these. Okay, tomorrow we will also be doing data wrangling. Sundar, I'm assuming you have already understood that how do we see the data? You have seen that iris data set, right? Yeah. When we find the actual utilization of all these things, when you are doing machine learning, Pradeep, so these are next steps. Okay, we will first have to load the data. Here you are doing loading the data, right? Let me show you. This is important for you people because you are still at the stage of understanding how do you do pre-processing. Now, once you are done with this, once you are starting to do machine learning algorithms, that's when sklearn module and stats modules will come into picture. Okay, That's the reason I've not explained much. Don't worry about these things. As I mentioned, these will be covered, but these are important, so we will be focusing on these. Yeah. What is the difference between iLocation and location? Both are similar. iLocation basically is integer location. You can call it as index location. So you're referring to your data using those positions. LOC is basically directly accessing the data using either the location or the name, the row name or the column name. Both are referring to your objects in your data, rows and columns. Both are same, but iLocation is only using numbers, integers. Yes, Gitanjali, you can, yeah, that's perfect. All these are looking now very typical. What do you mean by that, Pradeep? I didn't understand. Yeah, sure. All right, thank you. Good night, everyone.